So for question 5, we have this belt question. So the question is as such. The belt shown moves without slipping over two idle pulleys, so in this case pulley A and pulley B. At the instant shown, the velocity at point C is 400 mm per second to the left, and the acceleration is 600 mm per second square to the right. So I'm trying to determine the velocity, angular velocity of both A and B, and also the total acceleration of A and B. So that's required of this question. So the first thing that should come to your mind is the velocity and acceleration of C has to be similar or has to be the same as A and B because they are all acting on the same line. Okay, the only difference between pulley A and pulley B would be the angular acceleration and angular velocity. To do this question, let's recall vector cross product. Velocity is omega cross with r, and acceleration is alpha cross with r. So with that, we extract out the information that's given to us in this question. So you know the radius of A is actually 80 mm in the j direction. Because this is point A, I take this as my point of origin. So 80 mm upwards, so that's why it's in the j direction. And radius of B, I take this point of the origin, that's why it's 50 in the j direction. Okay, so once I have these two, I just write it down. Then I also write down the relationship between velocity of A, B, and C, which is the same, and it is a negative 400 mm per second. I take left as negative and right as positive. That's why it's negative 400. Because over here it says velocity of point C is 400 mm per second to the left. Left would be negative and right would be positive. And the acceleration of A, B, and C would be 600 in the I direction. So using the vector cross product over here, now I can write down whatever that I have. So velocity of A, which is the same as velocity of C, I write it down over here, so it's negative 400I equals to omega A in the K cross with 80J. So in planar dynamics, K, which is within the three-dimensional unit vector, K is pointing towards you, the reader. Negative K is pointing into the paper, or into the screen in this case. So in this case, I'm assuming that the angular velocity is running in the positive direction, which is counterclockwise. So within this channel, we will be talking about cross product a lot. So just take note that this angular velocity and angular acceleration is positive in a counterclockwise direction. Okay. So now I assume that this is rotating in the positive direction, which is counterclockwise. Then I can solve this. I can solve for this omega A. How? First, I will do the cross product. So when K cross with J, I will get negative I. So how do I get this? Just look at this diagram where this picture over here. So I use K. So this index finger A is pointing towards you, the reader. So you try to point at yourself. And this B is pointing in a positive y direction, which is this 80J. What you realize is this thumb, the result, will be pointing in a negative I direction, basically in a negative X direction. You try to pause the video and try it yourself and see whether can you get negative I. Or you can practice this vector right hand rule on some other questions as well. What you realize is once you do the cross product and you can solve for omega A, which is 5 radians per second, and this means our assumption is correct because it's a positive number. Hence, I just write down the vector of omega A is 5 radian per second in the K direction. So that's the answer for the omega A. To find acceleration, I use the same cross product. So I know what is the vector of A. I know what is the vector of the radius A. I just don't know what's the angular acceleration of A. Hence, using the same method, I'm able to find that the alpha of A is negative 7.5 radian per second square. Over here, I was assuming that it's rotating in the positive direction. However, I got a negative value. This means that my initial assumption of this accelerating in the counterclockwise direction is wrong. Hence, I have a negative value. So now I know that the vector of this angular acceleration is negative 7.5 in the K direction radian per second square. basically what this is trying to say is this is accelerating in a clockwise direction. Yep. Now in linear dynamics, you are taught that curvilinear motion has this general acceleration formula, or this general form. I'll explain to you what does each of these terms mean. So r double dot is the linear acceleration. Just take this for example, this figure over here. So I take this as ER and this is E theta. So r double dot is basically the acceleration along this ER direction. Okay? Centripetal acceleration is also within this ER direction. However, this is due to a rotating motion. Hence, there's a theta dot. Theta dot is same as omega. Okay? So this is negative r omega square. So which is the centripetal acceleration. Next, tangential acceleration is just the acceleration of that point over here, and it's moving in the E theta direction, which is over here, but then you can see this imposed over here, so it's moving here. Coriolis acceleration, you have been taught in lecture, so I'll leave it as it is. You can refer to the textbook or the lecture notes as well. So at this point, I know that this is a pure circular motion. Hence, I can say that r dot is 0 and r double dot is 0. Because this is moving in a circle, it doesn't cut into the radius. So you're moving in a circle, it does not go into the circle. Hence, r dot and r double dot is 0. I can simplify this whole equation into centripetal and tangential acceleration. Because r double dot goes to 0, r dot goes to 0. So what I have left is just this centripetal acceleration and tangential acceleration. So I'll put the formula over here. Now I put in all the values that I have. So r is the radius, theta dot is just omega, theta double dot is just the acceleration, and r is also just the radius. So once I do this cross product and just evaluate this, what I realize is the acceleration of A has two components in a negative j direction and a positive x direction. I can solve for the magnitude and I will get 2088.061. However, that is not enough because I also need to find out where is the placing of this acceleration vector. So I need to find theta as well. So theta is just tangent inverse of negative 2000 over 600 equals to negative 73.3. Why this is negative is because we take counterclockwise as positive, measured from the positive x-axis. If it's clockwise, then this will be negative 73.3. Okay? So this will be, so the vector of acceleration A is 2088 in the negative 73.3 degrees. So that's how you find the total acceleration at pulley A. Pulley B, you're using the same method. I won't go through in detail what you are supposed to do because it's just exactly the same method I did as before for pulley A. So here are my workings. You can check through. There's no difference between this computation of the pulley B and pulley A. So just pause the video and see whether can you understand or not. And if you do not understand, you can try to rewatch. Yeah. So that's all for question 5.